All right, so first we're going to talk about a point on the unit circle and using special right triangles inside the unit circle, and then I'm going to create the unit circle with you. First, I want to talk about that you can have a point on the unit circle anywhere on the unit circle. So these are just notes. You don't have to write this down, you just need to listen. And if we had a circle, so if you had points and they went around and they were all the same radius, it would eventually create a circle. And if you have a point anywhere along a circle, I'm not gonna create a circle. Okay, that's as close as I can make to a circle. And to get to that point, I would have to go some value of x and some value of y to get to this point, x, y, correct? Like that's how I would get to any point. Well, you could also get there straight shot, and that is representing the radius. So that's a triangle inside of the unit circle. We have a couple special right triangles that we're going to be seeing inside of the unit circle. And the special right triangles that we're going to see over and over and over again, we've got one that is a 45, 45, 90. And then we have one that is a 30, 60, 90. A 30, 60, 90 right triangle, and they have ratios that go around them. And you can remember them with x's, or you can remember them as x being equal to 1. It doesn't really matter. The ratios of the side lengths for a 45, 45, 90 triangle, we've got 1, 1, and then if you did the Pythagorean theorem, this would be the square root of 2. So 1, 1, square root 2. And then we have the 30, 60, 90 triangle, and it is, I always remember to label it starting across from the 30 degrees because it's the smallest side length. So this is 1, 2, square root 3. What is the square root 3 about? What's the square root of 4? 2. What's the square root of 1? 1. So it's in between two perfect squares like 1 and 4. So it's got to be somewhere in between 1 and 2, right? Okay, so the hypotenuse has to be the longest side. That's how I remember that the hypotenuse has to be 2. And this has to be the middle side. So these are side lengths for our special right triangles. We also have the 30 degrees. It's the exact same triangle. It's just turned to where you have like this 30 and then 60 and 90. And that one has side lengths across from 30. We've got 1. The hypotenuse is always 2. And then we have the square root of 3. So inside the unit circle, we have 45 degrees, we have 60 degrees, we have 30 degrees. Nod your head if you remember seeing these angles in that first quadrant. And then everything else after that are multiples of 30, 60, 90, 45, all the way around the unit circle. So from here, let's see. One thing that I want you to remember is that x goes with cosine and y goes with sine. That's really big. This is like x, this is like y. So when you get to any point around the unit circle, those coordinates are going to be built off of X and Y. And we're going to also use those ratios. So like if I wanted to know the cosine of 45, well, cosine is adjacent over hypotenuse. So I get 1 over the square root 2. And there's this thing in math where we like to rationalize the denominator. So you didn't see any 1 over the square root of 2 when you created your triangle. Your ratios were square root 2 over 2. And all that they did was rationalize the denominator. Way back in the day, calculators couldn't handle a square root in the denominator, so you had to fix it. Now we can, so I'm not really sure why it's necessary, but a lot of books, a lot of resources are still going to rationalize the denominator. So again, you have this ratio 1 over the square root of 2, but you don't see that in your unit circle. What happens to rationalize the denominator? We multiply by the square root 2 over the square root 2. And we end up with, in the numerator, 1 times the square root 2, which is the square root of 2. And then in the denominator, we would get square root 2 times square root 2, which you multiply the stuff underneath the radical. So 2 times 2 is 4. What's the square root of 4? 2. That's why you see this value on the unit circle. It's the same thing. So let's put some stuff on our unit circle. So first thing I'm going to do is go around, and I'm going to do this in degrees. On your paper, it says which one is degrees. Is it the dashed line or the solid line? Solid line. Okay, let's start and let's go around in degrees. So first we have 0 degrees. And then we have 30 degrees. We have 45 degrees, 60, 90. And then we keep going. We have 120, 135, 150, and 180. If you label the 45 degrees and you go through and they're all the ones in the middle. One trick to doing that is that has a 4, and then this one has a 3, 5, and then this one has a, what's this one? Goes down by 1s. So if this is a 4, this turns into a 3, this turns into a 2. So we get 225, and then we're going to go down by 1 again. And so this is going to be a 315. So for the 45 degree reference angle, the tens place decreases by 1, 4, 3, 2, and then a 1, and it increases by 100 each time. So that's just a trick for the 45s. And then the others, you can just count by 30s or count by 3 out of 0. So 30, 60, 90, 3, 6, 9, 12, 15, 18. And then this one's going to, oh, I put these in the wrong spot. Okay. Then we've got 210, 240, 270, 300, 330, and then you have to remember that you end at 360. So sometimes I don't do them necessarily in order. I mean, the first quadrant's pretty easy to do in order, but after that, I label the 45-degree reference angles because those kind of mess me up. And then I can just count by 3 and label the rest and add a 0. So that's how I do degrees. For radians, you start at 0 degree, or sorry, you start at 0 radians. And another one that I know is that you end at pi right here. Half of that is pi over 2. Half of that, half of pi is pi over 2. Half of a half is a fourth. So right here, it's pi over 4. And then the way that I remember these two is they flip or they switch. So the smaller one's pi over 6, because if you cut something into 6 pieces, it's smaller than if you cut something into 3 pieces, and it's actually built off of pi. So how many times do we cut pi? And so if you look at the 30 degrees, there's 1, 2, 3, 4, 5, and 6 pieces if you start at a piece this big. So it's pi over 6. And then if you cut them this big at 60 degrees, there's only 1, 2, and 3 of them. So it's pi over 3. So the pi over 4 and the pi over 6, you can use those to count all the way around the unit circle, and then you can reduce if you need to, or you can memorize how they go. I mean, it's totally up to you, but it's just fractions. So if you go through and you look at the pi over 4s first, so this cuts it into 4 pieces. So there's 1 piece, 2, 3, and 4. And so if this is 1 pi over 4, this is 2 pi over 4 and 2 pi over 4. I'll write it up here. 2 pi over 4, it reduces to pi over 2. So I'm able to check myself that this one matches. Yep. And then here it would be 3 pi over 4. So I've got 1, 2. So I'm counting by the slices that are a fourth. 2 pi over 4, 3 pi over 4. This would be 4 pi over 4, which reduces to just pi. 4 pi over 4, 5 pi over 4. 6 pi over 4. That one will reduce 2. They are both reduced by 2. So I get 3 pi over 2. That's what I'll write right here. 3 pi over 2. So 6, 7 pi over 4. And then all the way at the end, it's 8 pi over 4, which also reduces to 2 pi. So I'm going to go through and I'm going to erase those because I don't need them. I just reduced them. So I used those to help me create it, but I don't need them. They're not in my circle. So now I can go through with the pi over 6s. And so I'm going to count by pi over 6, and this will take care of the rest of my circle. So 1 pi over 6, 2 pi over 6, and that reduces, pen, 2 pi over 6 reduces to 1/3. This would be 3 pi over 6, which reduces to pi over 2. So 3 pi over 6, 4 pi over 6, which will reduce to 2 pi over 3. So 5 pi over 6, 6 pi over 6. Again, this is helping me make sure that I'm on track because it should reduce to the same thing. So 6 over 6, so pi, 6 pi over 6, 7 pi over 6. And I'm skipping the over 4s because those don't have the same denominator. So 7 pi over 6. And then the next one would be 8 pi over 6. That's going to reduce 4 pi over 3. So 8 pi over 6. This one's 9 pi over 6. So every other one you have to, you'll see the ones you have to start reducing. And that reduces to 3 pi over 2. So I'm still on track. 9. So this would be 10 pi over 6. And then 11 pi over 6. I need to reduce this one. 5 pi over 3. And then I end up with 12 pi over 6, which reduces to 2 pi. And so again, that was just counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. And then you reduce those fractions that can be reduced. So there's all my radians. And again, you have to commit these to memory. You do not have a calculator on your test. Any questions on how to create the radians? So you don't necessarily have to memorize it. You just need to know how to count all the way around the unit circle. To create your coordinates, the axes are pretty easy. It's a unit circle, so you're going a unit of 1. And so you go up, down, left, right, a unit of 1, and the other value is a 0. So if I'm starting over here, then I am going right 1, and I'm not going up or down. So my coordinate is 1, 0. Actually, I'll write those in a different color. Let's make those 1. So I'm going to have 1, 0. And then if I go up to 90 degrees, I'm not going left or right. So I have a 0 for the X value, and I'm going up 1. If I'm going to 180, I'm going left. So it is -1, and I'm not going up or down. So it's 0. If I go straight down, I'm not going left or right. So my X value is 0, and I'm going down. So my Y value is -1. Any questions on how to find the values at the axes? You're good. Yes, no? We good on those? Going left, down, upright. It's just values of 1, -1, and 0. All right, now we've got the fun ones. From here, the easiest one to remember is the 45 degrees. You are moving it's right in the middle. So you're going the exact same X distance as you are with the Y distance. And we already talked about over here that if you were talking about cosine of 45 degrees, it would be 1 over square root 2, which we're going to rationalize the denominator, and we get square root 2 over 2. To be honest, as far as the coordinates go, you only have to remember first quadrant, and there's very little to memorize. All the way around the unit circle, it's the same values. The only thing you have to remember is where things are positive or negative. So in this first quadrant, everything has a positive X and a positive Y. In quadrant 2, and this is quadrant 1, just as a reminder. In quadrant 2, every coordinate will have a negative X value, but a positive Y value. In quadrant 3, everything in quadrant 3 will have a negative X and a negative Y. In quadrant 4, what do we have? Positive, negative. We're moving in a positive X direction, but a negative Y direction. And so another way you can think about this, for this one, all trig functions are positive. Everything, sine, cosine, tangent, even their reciprocals, they're all positive. In quadrant 2, the X is negative. X goes with cosine, so cosine is negative. But the Y, which goes with sine, it's positive, so sine's positive. In the third quadrant, you're going to have both a negative cosine and a negative sine. In the fourth quadrant, you're going to have a positive cosine, but a negative sine. Something to keep in mind. So let's fill some stuff up. So the coordinate for 45 degrees, we've got square root 2 over square root 2. Square root 2, not square root 2 over square root 2, square root 2 over 2, and square root 2 over 2. That's what I meant to say. Square root 2 over 2 and square root 2 over 2, they're the same. And it's the same all the way around the unit circle. The only thing is that in the second quadrant, I need to make all my X values negative. In the third quadrant, I need to make my X's and my Y's negative. So I'm just going and putting these so I don't forget. In the fourth quadrant, only my Y's are negative. So I'm going to go put my Y's. So all the way around the unit circle, this middle value will be exactly the same. The middle coordinate, that's what I meant to say. So I'm going to go put it all the way around my unit circle. For these, they're pretty easy. You just have to remember one of them. So I can go look back at my triangles. And so I'm starting with 30 degrees. The one that I've committed to memory to build the other two coordinates is that the sine of 30 degrees is 1/2. I don't know why. That's what I remember. And so if I'm looking at the 30-degree triangle, the sine, which is opposite over hypotenuse, it's 1/2. The sine of 30 is 1/2. So I remember that the sine of 30, sine goes with the Y value. The sine is 1/2. Sine of 30 degrees is 1/2. And then I could go look at my special right triangle, the cosine adjacent over hypotenuse, square root 3 over 2. So I get square root 3 over 2. That is the same coordinate all the way around the unit circle with a 30-degree reference angle. So this is 30 degrees from the x-axis. This one matches with this one that is also 30 degrees from the x-axis. It's also going to match with this one, which is 30 degrees from the x-axis. It's also going to match with this one, which is 30 degrees from the x-axis. So these 4 angles are reference angles. They all have the same coordinate. The only thing changes is what's positive and negative. So I'm going to go put those in there. And for my 60-degree coordinate, all I do is flip the values because it's actually the same exact triangle. The only thing that's different is it's turned. So the only thing that changes is you switch the X and the Y values. So this becomes 1/2 and then square root 3 over 2. And then I go put that coordinate all the way around the unit circle, and it's with the 60-degree reference angle. So this is 60 degrees from the x-axis. So is this one 60 degrees from the x-axis. So is this one 60 degrees from the x-axis. And so is this one 60 degrees from the x-axis. Hello? I can. That's okay. I'll let them in. Yeah, no problem. All right. Oh, I know that. I've been knowing that. Okay, I'll let them in. You're welcome. Bye. Sorry, I gotta let people into the TSI test. Okay. So we have filled out our entire unit circle. Yay! Hopefully that was helpful, especially for those of you that just kept writing it down from a picture. Was that helpful? Hopefully. I think that there are a lot of tips and tricks out there, but everybody does things a little different. So a couple of things that I want to show you so that you can remember. If we look at the ones that have, so these coordinates, like I feel like everybody's got to have these in the bag. Those are easy. These are the ones that we kind of get struggle with. What is the denominator for everything? 2. Done. Easy, right? You know that all of them have a denominator of 2. Easy. All right. Let's look at a pattern. So if you look at the numerators, what's the square root of 1? 1. So another way to remember is this is like square root 1, which is just 1. 1, 2, 3. And it goes the same the other direction. 1, 2, 3. There's another pattern that you can look at to see. So again, 1, 2, 3, and 1, 2, 3. I don't care how you memorize it, but you've got to memorize how to create the circle. To be honest, you really have to know this first quadrant because you can build the rest if you need to. You don't usually get a question that asks you about everything. There's a lot of stuff on here. You can't possibly be asked about everything. Now on this homework, you might, because I ask you a lot of questions. But on a test, you're not going to have to know everything. So you don't necessarily have to create everything. All right, moving on. Let's use the unit circle. So here's a unit circle. It's all filled in. It's the same. So how we use our unit circle to help us. Now, here's the deal. If you type this into your calculator, aside from when you get 1/2, which the calculator will tell you 0.5, when you get values like, what kind of a decimal do you think that the square root 3/2 is going to give you? What do you think that's going to look like? Do you think it's going to be nice like 0.5? No. So if you turn in your homework and it has decimals on it, you get a 50. I'm not giving you any points because you can type something into the calculator. That is not helpful. You have to use your unit circle. Your answers have to be in fractions. So if I'm asking for the sine of pi/2, this is the angle, this is the coordinate. So again, this is the angle. Let me write that down. This is the angle, and this is the coordinate. So this is looking for the y part of the coordinate. So you are looking for this is the x, y. Let me move my arrow because this is more specifically looking for y. When you got cosine, this is the angle. You go find that angle, and then you have an x, y coordinate. You're looking for the y value of the coordinate because cosine goes with x. So for sine of pi/2, pi/2 is also 90 degrees. I can go find pi/2 or 90 degrees, and I go and I look for the y value. So what is sine of pi/2? 1. That's it. That's your answer. 1. What about the cosine of pi/2? What? 0. Well, we didn't do anything with tangent. I'm going to back up. So let's go back. And let me write these down. So we have x, y. is the same thing as cosine of an angle and sine of an angle. Tangent. We learned about tangent. Tangent. What is tangent equal to? What over what? Sine over cosine. So that means that tangent is going to be y over x. So if you look at your coordinates, it's going to be y over x. So we can go and we can add tangent values all the way around our circle. So for this one, we have 0 divided by 1, the y divided by the x. So I would have 0 divided by 1. What is that? What's 0 divided by 1? 0. Okay, so tangent of 0 is 0. Let's go straight up. This one's 1 divided by 0. What's anything divided by 0? Undefined. Only Chuck Norris can divide by 0. We are mere mortals. We cannot do it. So it is undefined. Over here, it's 0 divided by -1. What is that? 0. And then what about -1 divided by 0 straight down? What's that? Undefined. For the rest of them, all the denominators are what? 2. So when you have a fraction divided by a fraction and the denominators are the same, they cancel out. So really, you're just looking at the numerator divided by the numerator. Okay, let's make life easier for ourselves. So it's always the second value, or the y, divided by the x. So this one is 1 divided by the square root of 3. You're never going to see it like that. They like to rationalize it. So that turns into square root 3 over 3. The next one, I'm going to have square root 2 over square root 2. What's anything over itself? 1. The next one is square root 3 divided by 1. So it's just the square root of 3. And guess what? All the way around the unit circle, it's the same. So if this is square root 3, this is also square root 3, except for it's negative because one of them is negative. So you get negative square root 3. And then all the way straight down, if I have a negative divided by a negative, that becomes a positive. So it's positive square root 3. So if you don't already have tangent added, let's add tangent. That's good stuff. So over here, we have also square root 3, but one's negative, one's positive, so it will be negative. Also, it's kind of important to know that tangent is positive here and positive here and negative in these two quadrants. And I can go around. For my 45-degree reference angles, I have 1 everywhere. This one is a -1. This one is a +1. This one is a -1. And then the other one is square root 3 over 3. So this one's negative square root 3 over 3, positive square root 3 over 3, and negative square root 3 over 3. All right, we can add tangent to anything if we need it. Now, I don't think that it's necessary to use your time to create tangent everywhere if you're doing a test, unless it asks you, unless you have to know tangent or cotangent, because it's pretty easy to come up with them. So we've added radians, degrees, coordinates, and tangent. So we know lots of stuff on our unit circle now. So coming back to our problems. So tangent of pi over 3, pi over 3. I remember that the 3 goes with the 6. So this is the same thing as 60 degrees. So over here at 60 degrees, I don't have a tangent here, but like I said, it's pretty easy to figure out. I'm going to look at my numerator. So this would be the square root 3. So tangent of pi over 3 is positive square root 3. And again, I remember this because it is y over x. Cosecant. Who does cosecant go with? Sine. So I'm going to go find sine of pi over 4. I'm going to find sine of pi over 4. Let's go look for that. So sine of pi over 4. Oh, I remember that anything over 4 is going to be square root 2 over 2. Anything over 4. So over here, at sine of pi over 4, or anything over 4, looky, that's over 4 too. And it's still square root 2 over 2. Ah, that's over 4. It's still square root 2 over 2. That's over 4. It's still square root 2 over 2. It doesn't matter what it is, sine or cosine around the unit circle, it's square root 2 over 2. You just have to remember positive or negative. So everything is positive in first quadrant. So sine of pi over 4 is square root 2 over 2. Let's remember for a second, what was it before we turned it into square root 2 over 2? It was 1 over square root 2. That's kind of helpful to remember because what we have to do here, when you have cosecant, a reciprocal just flips your fraction. So if it just flips your fraction, then I get square root 2 over 1, which is just square root 2. Cotangent. Cotangent goes with which function? Tangent. So I'm going to go find tangent of 0. Well, tangent of 0, remember, I'm going to look at that ratio and I'm going to flip the ratio. So I have to look at the ratio. So tangent is y over x. So it's 0 divided by 1. So tangent is 0 divided by 1. So when I look at cotangent, I'm going to flip that ratio and I'm going to have 1 divided by 0. Well, what's anything divided by 0? What's anything divided by 0? Undefined. Cosecant again. What goes with cosecant? Sine. So I'm going to look for sine of pi over 6. So pi over 6, I remember that over 6 goes with 30 degrees. So it's this one, pi over 6. And I have my x value is cosine. My y value is sine. Remember, this is the one that I've committed to memory, pi over 2. So I have, 1 over 2. 1 over 2. So what is cosecant of pi over 6 then? 2. Y'all see what we're doing here? All righty. So what we're going to do now is we are going to flip to the next few questions. So I want us to do these questions. So I'm going to have you guys do these questions and then we're going to put them up on the board and see if we do them correctly.